Hi, hello everyone, good day. So today I will be discussing our first MELC for the fourth quarter of Mathematics 9, which is illustrating the 6 trigonometric ratios. And what you will be learning from me is at the end of this video lesson, the learners would be able to illustrate the 6 trigonometric ratios and what those are: sine, cosine, tangent, cosecant, secant, and cotangent. And solve for the missing parts of the right triangle using the trigonometric ratio. I have attached here a few examples so you will be able to learn how to find the values for the missing parts of a right triangle. Now when we say ratio, we are comparing two quantities because in a triangle, what it simply means is that their angles and the sides are related to each other. I have your right triangle. Let's name our triangle as triangle A, B, and C, wherein these capital letters stands for the measure or the name of our angle, and the lowercase a, b, and c stands for the measure of the side. Now, you want to find out what is the relationship of a with respect to c, as well as b with respect to c. Using this angle right here, we'll just name our angle as theta. Just like in our body parts, the length of our arm span is equal to the measure of the length of our height. Now you're learning something new from me. Same with the triangle. Even if I want to make this triangle as enormous, as big as it is, so our angle theta will become larger, and this length here, opposite to the angle, would also increase in height because it corresponds to the size of the angle. So that simply means this opposite side is directly related to the angle opposite to that one. And don't you worry, in solving for the measures of trigonometric ratios, we have our mnemonic patterns. That's all we need to remember. So SineCosine, wherein S stands for lane, O is for the opposite side, and H for hypotenuse. Same with CAH. C stands for cosine, A for adjacent, H for hypotenuse. And we got the third one, T or TOA. T stands for tangent and opposite over adjacent. Tangent means, like, if I draw a circle here and I put one line which has one point touches the circle, that's what we call as tangent. You actually learned that in the past. Now this side here, A, is opposite to our angle theta. We call it as opposite, and the closest side to our angle theta, which is to the base, is what we call as adjacent, and the longest side of our triangle, which we called as hypotenuse. Now if we will be using this angle B, and it has a specific measure, whether there is or it's only represented by a variable or a symbol theta, if you will be using this one, the opposite side of the angle B would be this one, the B, lowercase b, and its adjacent side would now become this one. Let's go back to our reference angle theta, which is our angle A. So the opposite of that one is A, and the adjacent is the B. Now what those three trigonometric ratios are. Let's start with sine. Sine is abbreviated as SIN, but we do not pronounce it as sin. We pronounce as sine. S-I-N-E, not sine, not S-I-G-N, but sine. The second one is cosine, abbreviated as cos, C-O-S. And the third one is tangent, abbreviated as tan, T-A-N. Now you might be asking me where the sine and cosine comes from. Well, the word sine, which comes from the Arabic word that means bowstring, or simply means the cord. And we'll introduce sine, by the way. Let's go back to that slide. Well, sine was introduced by Aryabhata. Yes, once again, sine, which means bowstring or cord. You know what cord is, right? It's a line segment. part of your circle as well. Sine was introduced by Aryabhata in India during 476 to 550, and from there in India it penetrated to the Muslim world, where several astronomers developed trigonometry further. One notable figure was Muhammad ibn Musa al-Khwarizmi, and in the early 9th century AD, Muhammad ibn Musa al-Khwarizmi produced the accurate sine and cosine tables, which we can now find from the store, and the first table of tangents thanks to him. He was also a pioneer in spherical trigonometry, so that's a great contribution. Now you're learning something new out of our topic. Let's go back to our right triangle ABC. Just remember your mnemonic pattern SOHCAHTOA and sine theta. This one stands for opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse, and your tangent is opposite over adjacent. Now let's try a few examples. Let's find sine theta using this figure here, where in our opposite side A is equal to 12 and hypotenuse is 60, and our adjacent still represented by a variable lowercase b. Sine theta is opposite over hypotenuse. All you have to do is substitute those values into your formula. If you know where your your opposite and hypotenuse is, then you will be able to put it here. That's why we have familiarized ourselves with those terminologies earlier. Sine theta, the opposite side is 12, so we got the numerator as 12, denominator is 60. Reducing it to lowest terms, sine theta would give you 1/5 for 12 over 60. Now let's try to find B, the missing part of our right triangle, using our trigonometric ratio in the form of cosine. Now we have here the value, specific value for angle A, which is 50 degrees. So it's no longer theta but 50 degrees. So remember your SOHCAHTOA. Since we are using cosine, so that will be CAH, wherein cosine theta is equal to adjacent over hypotenuse. So since we have a specific value 50 degrees, we will just write cosine 50 degrees. That will be equal to B over 60. Now what is B? B is the product of its denominator 60 times the value of the cosine 50 degrees. But where would you get the value of cosine 50 degrees? You may buy the cosine and sine tables, or you can simply use your scientific calculator. That will be fast and easy. If you want to know how to set the mode for the calculator in looking for or finding a specific value for the trigonometric functions, then you may wish to click the link below. I will attach it together with this video for a video tutorial. Anyway, it's quick and easy. All you have to do is set your calculator to degrees, and once it is already done, then you would be able to see the three letters DEG on top of it. That stands for degrees. Then you press the key cos, COS, followed by the number 50 and the equal key. Then you will get the specific value for cosine 50 degrees. What is that? Cosine 50 degrees is equal to 0.64. So if you will be multiplying that 160 times 0.64, you will get the value for B, which is 38.4. Alright, now let's try the third example using the tangent theta, that is opposite over adjacent. All you have to do is substitute the values. Your opposite is 20, and your denominator, which is your hypotenuse, your adjacent, which is 5. So that will be 20 over 5 will give you 4. So your tangent theta is equal to 4. Now let me introduce to you the other three trigonometric ratios which we got from its reciprocal. So let's start with sine theta. Since sine theta is opposite over hypotenuse, its reciprocal will be hypotenuse over opposite. That is what we call as cosecant, or abbreviated as CSC. CSC stands for Civil Service Commission. So okay, I'm kidding, that will be cosecant. So although we abbreviated the cosecant as CSC, we still pronounce that one as cosecant. Let's go with the cosine again. Cosine theta is adjacent over hypotenuse, wherein its reciprocal would be hypotenuse over adjacent. That is what we call as secant. Secant is abbreviated as SEC, S-E-C, but we still pronounce that one as secant. Then tangent theta is equal to opposite over adjacent. That will be adjacent over opposite for its reciprocal, which we called as cotangent, or abbreviated as COT. Now you get the 6 trigonometric ratios there. Now let me try another example using one of those reciprocal of sine. Let's have a different triangle here. Triangle I hate you. That's IHU. And look at the opposite side. For the theta is 3. Our adjacent is the lowercase h, and the hypotenuse is 9. Just remember your pattern, mnemonic pattern SOHCAHTOA. If you will be finding out for the cosecant theta, that will be the reciprocal of sine. Hypotenuse over opposite. So just try to find your opposite and your hypotenuse. Your hypotenuse here will be your numerator, which is 9 based on the figure, and the opposite is 3, so that will be cosecant theta would be equal to 9 over 3, which would give you 3. What about secant? Secant theta, which is hypotenuse over adjacent. Your secant theta will be 9 over h. 9 is your hypotenuse again, and your adjacent is h. Cotangent theta is adjacent over opposite. Well, in your cotangent theta will be equal to your h over 3. Because this is your adjacent and your opposite is 3. Alright, so now you do have now the examples on the illustration on how to find the missing value, missing part of a right triangle using its reciprocal of trigonometric ratio, the cosecant, secant, and cotangent. So we have discussed so far different examples, different problems that requires the application of any of those 6 trigonometric ratios. So I'm pretty much sure that you will be able to master this one. This is just quick and easy. It's just logic, and everything will come smoothly to your mind. So just to summarize what you have learned, please complete the sentence. In a right triangle having an acute angle, the sine theta is the ratio between what? The opposite and hypotenuse. If you will be asked what is the relationship of the opposite with respect to hypotenuse, then your answer would be sine. Or if you will be asked what is the relationship of hypotenuse with respect to opposite, just remember that they quote hypotenuse first. So that will be the reciprocal of sine, which is cosecant. What about this cosine theta is the ratio between adjacent and hypotenuse. And the tangent theta is the ratio between opposite and adjacent, wherein its reciprocal is cotangent. And the reciprocal of cosine is secant. Alright, so we got here another example, solving a right triangle given the line of the hypotenuse and the measure of one acute angle, just to enhance your skills further. Using this figure here, triangle ABC, wherein our hypotenuse is equal to 27 and our angle A measures 58 degrees. Now let's try to find the value for the measure of the angle B. So based on the given figure, we know that angle A and B are complementary angles. What does it mean when we say complementary angles? The sum of those two angles add up to 90 degrees. So angle B plus angle A should be 90 degrees. Wherein your angle B would be 90 degrees minus 58 degrees, so that will give you 32 degrees. So it's just logic. But if you still want to use the trigonometric ratios for that one, you can also do so. Just follow the pattern. Now I want you to answer the following activity, that is to assess further what you have learned, that you have mastered, just to make sure that you have mastered on how to find the missing value for the missing value or the missing part of the right triangle using the application of the 6 trigonometric ratios, whichever would be applicable based on the given figures, and as well as how to illustrate that one. So what makes you special? I have here figures. All you have to do is just answer what is being asked, just based on the figure here. You can pause this one if you need more time. And I will also attach the clip of the image. Alright, so that's it. That's the end of the lesson. So once again, if you want to check out the link for the video tutorial on how to use the scientific calculator to find the values of trigonometric functions, I have attached here a video link. I'll paste it as well on the video. And for interactive quiz. I know that you will be excited for this one. If you want to learn more, I have prepared myself for this one, so you can actually try this one out. I want you to try answering my interactive quiz game via liveworksheets.com. It's very interesting and user-friendly, so you would enjoy it. So as long as you have the internet connection and you can go to the link, I have here the link. Alright, so that's it. That's the end of my lesson. What's next? Next would be the special of finding the trigonometric values for our MELC 2. That is finding the trigonometric ratios of special angles. Alright, so if you do have a question, you can just message me. I hope that you have learned something new from me from today's lesson, and I will attach the rest of the video links for the rest of the topics that would serve as your guide in answering your summative test. Thank you, good luck, and stay safe. Goodbye.